Okay, I'm not sure we'll have the time in the end for the demo, but at least we have the slides going already. So, hello everyone, sorry for keeping you waiting. My name is Alberto Ravelli, and today we're not going to talk about SQL injection. Something about me, mostly a snowboarder, security researcher when I'm bored, party addict, that's what people say, and if you have time for some Uzo later, I'm happy for that. I also happen to be the author of SQL Ninja and will touch this quite heavily during the talk. I'm also the co-author of Heyoka, which is a DNS tunneling tool. We'll also touch this. I've written parts of the book SQL Injection, Attacks and Defense, published by Syngress a while ago. And to pay the bills, I work for Digital in London as a senior consultant. And by the way, we're hiring, so if you can cope with the bad London weather, we're looking for people. So let me start with a little rant, and just purely personal, on SQL injection. I might have developed a SQL injection tool, I might have written stuff on a book about SQL injection, but today I'm not going to bore you to death with any or equal 1 equals 1 or anything like that. The reason is that, in my personal opinion, there hasn't been any real new research on SQL injection since 2005, and this includes SQL Ninja as well. In my opinion, the last really pure research paper was David Litchfield in 2005 when he introduced data mining with inference-based SQL injection. Since then, in the last 5 years, it's been, well, exploitation of specific DBMS features, post-exploitation, lots of weaponization, sometimes good, sometimes not too much, but the nature of the attack, the nature of the problem is clear. It's something different what has happened. It's not real research on SQL injection. And the cause is that, again, the root cause is clear, faulty semantic separation between code and data. Unlike other well-understood problems, the answer is pretty much there too. Prepare statement, you pretty much solve the problem. And most modern web development environments now use prepare statement pretty much by default. Is it still possible to fuck things up? But I would say that it really takes some effort in order to do that. So in my opinion, SQL injection is probably going to kind of disappear in a few years. Obviously there's going to be a lot of legacy applications. So they're still going to be there, but I would say that they will see less and less of that. And hopefully it will mean that there will be fewer companies that make lots of money out of clients, selling them like very weak application penetration tester. In the meantime, however, we can still have fun. We can still add some new feature to existing tools, which is what I'm doing at the moment, among other things, on SQL Ninja. So nothing really SQL injection, purely SQL injection related, but still something that we can play a little bit. So if you haven't used SQL Ninja before, basically it's an exploitation tool that exploits SQL injection vulnerabilities on Microsoft SQL servers. It's a pure exploitation tool. It doesn't look for vulnerabilities. It doesn't extract data. Its focus is purely taking over the database server on the back end. The idea is to follow the Unix philosophy. A tool should do one thing and should do it well. That's all. Or maybe I'm just very lazy. What does it do? Well, fingerprint of remote database, privilege escalation using, SA password brute forcing on SQL Server 2000, token kidnapping. In the next version, it will also do privilege escalation with KTRAPOD. Upload of any binary using only ASCII-based traffic. Remote OS access, you can use NetCat. It integrates with Metasploit. If there are no open ports between UDP or TCP between you and the server, you can access it. You can still have interactive access through a DNS tunnel. ICMP tunnel is on the way, and also does some web application firewall evasion through various tricks, some of which also are on the way with the next version. So I'm going to quickly go through some of the new things that either are in the latest version that has been released 3 weeks ago, or that are going to be in the next release, which I plan to release in probably less than 1 month. So, uploading file to the DB server is, well, it's pretty much straightforward if you have, if everything is open. However, if you have a firewall in between, things are not just as easy as just creating an FTP script, sending it over, and get a remote box to download the things you're trying to send. So, one of the tricks that have been used for years, this is nothing new really, is to use the old MS-DOS debugger, which is present by default on all Windows machines up to 2003, I think. I'm not sure about 2008, maybe not by default. Basically, the idea is to recreate a debug access script, so a series of instructions for the debugger, and use this instruction to actually recreate the binary on the remote machine. So, for instance, that's the beginning of netcat.exe, so an executable. The script that I use is, well, I create this netcat.tmp. I put the size of the file in a 6 registry. Keep in mind that we're talking about the old MS-DOS debugger here, so we're talking about in 16-bit. We fill the whole segment with null bytes, starting from X100, because the first 156 bytes are reserved for the debugger, and then we just write in memory all the values that are different from 0. This trick basically allows us to create a binary file with a very limited number of scripts, so creating more compact scripts. At the end, we write the file to disk W, we create debug.exe, and we have a binary file on there that we can use. And we can do this only using purely ASCII requests without needing to transfer any binary data. So just with using like normal get or ports requests, you can generate binary files on the other side. At the end, when the script is uploaded, you just feed it to debug.exe, bang, you have your file there. The only problem is that since debug.exe work on a 16-bit memory space, we can only create executable up to 64 Ks inside. So one of the things that I did in the latest version of SQL Ninja is to bypass this limitation. Now, I'm not the first one to do that. There are other solutions that have been proposed. Lots of them basically involve uploading a stager. You upload a small UU decoder as an executable using the debug.exe trick. That executable is smaller than 64 Ks. When you after you upload it, then you upload the UU decoded version of what you're trying to upload, and you encode the UU decoder in order to bring it back to the original binary format. It works, it's fine. However, I prefer to use a far simpler trick. I split the executable into chunks that are 64 Ks, upload them separately, and then just go copy in order to put them together. And much simpler, but still very effective. And I just discovered that SQL Ninja is not the only tool doing that. SQL Map uses the same trick to upload files of unlimited size. Privilege escalation. As I mentioned before, it's possible to escalate to SA using OpenRollset if the remote server is 2000. I haven't implemented yet MS-09004, which allows, pretty much exploits a heap overflow, allowing a normal user to escalate to database administrator. Basically because in my tests so far there is quite a high risk of crashing the service, but it's kind of still working on it. However, I'm mostly having fun with the OS level exploitation. So there's token kidnapping, it's supported. It has been patched by MS-09012. However, Cesar Cerruto, the author of the original token kidnapping attack, apparently is coming back with a revenge this summer at Black Hat, so definitely worth having a look at it. What I'm implementing in the next version is the anti-Keytrap kernel stack switch attack that was released by Tavis Ormandy. Oops. Okay. By Tavis Ormandy last February, I think, which is quite a cool attack. Basically, It exploits the virtual DOS machine, which is used by modern processors in order to execute legacy MS-DOS or 16-bit Windows program. Basically, what happens is that the privileges separation from ring 3 to ring 0 has a few faulty assumptions that can be triggered in order to launch an executable, call the VDM, and use that when returning to 32-bit mode to forge a fake kernel frame and obtain system privileges. The good thing is that it doesn't really need any buffer overflow, any memory, just mesh any memory, so it's fairly stable. There's very little risk of breaking anything. Even if a couple of times I had a few blue screen of death on some virtual machine that actually some people here this morning witnessed it. So the original exploit actually spawns at DOS prompt, and so you get a nice shell with system privileges. Meterpreter now has a key trap to the attack built in, so it's fairly easy to use. However, it might be in a SQL injection attack, it might be that you need to escalate privileges in order to be able to use Meterpreter. So we get in a sort of like chicken and egg problem here. We need to escalate privileges in order to use a tool that will allows us to escalate privileges. So what I'm doing, well, what I did is going to be in the next version of SQL Ninja. Instead of spawning a shell, I modify the exploit so that the exploit looks for the process ID of the SQL server and performs the attack on that process, elevating its privileges to system. Why we might need to do this? Let's take a possible scenario. The DB server is behind the firewall that does not allow any TCP or UDP connection, so we cannot directly use Meterpreter. However, the DB server can resolve external names to the internal DNS server, which means that we can set up a DNS tunnel and use Meterpreter over the DNS tunnel. That's fairly easy to do. However, a problem of a standard DNS tunnel is that you have one box, the box that is the tunnel endpoint, that all of a sudden generates a massive amount of DNS requests in order to transfer all the data. And it might be that there is some IPS there that just figures that out and just detects the tunnel endpoint before we can actually do anything. It's very unlikely. Like in my experience, like probably 98% of the clients I've worked with would not be able to detect that. But what I really want to be able to do is actually like fuck those remaining 2%. The solution for that would be to use spoof DNS request, so that we can actually spread the signature of the tunnel across all hosts on the subnet. However, in order to use spoof DNS request, we need administrative privileges right away. I'm not going to go through like how a DNS tunnel works. I mean, also because we don't have much time left. I assume that pretty much you guys know how it works. Basically, you just encode your data in the host name. The host name is resolved by the DNS server. The data is received by our box, decoded, and then on the response, which is a TXT response, we send the data down. Very simple, plenty of tools to do that. So, in order to spoof, to do this trick using spoof traffic, as a proof of concept, last year I developed Heyoka, which is, again, a data exfiltration tool that uses spoof traffic to create a bidirectional communication between the two hosts. It uses binary data instead of how technically data should be encoded in a DNS request and response. Basically because I found out that most DNS servers, for instance bind, they all allow binary data to be in the host name and in the TXT response, which means that we can actually shove more data in there and have a faster tunnel. I'm not going through all the technical details of how it works, but just to give you a little bit of understanding of how we can create a bidirectional tunnel using spoof requests. That's pretty much how it works. We split two different communication channels In order to send data out, we use spoof packets that are forwarded by the DNS server and are received by our host. The response will be obviously sent to some other IP addresses, so the responses to the spoof traffic cannot reach the original host. However, at the same time, we create another small tunnel that we use only to receive data back. So we use non-spoof packets with just no data at all in there. So we don't need many of them. They can have very small footprint, and these packets are sent back by the requests are answered and the responses reached our host, and the other DNS tunnel endpoint is able, using this non-spoof channel, to actually give issue command to the host that we've taken over. Tell this host if there is any need to retransmit anything, to give further instruction, upload data in there if it's needed. Basically, this is what happens. There is only one box actually is creating the traffic, but it appears that all these other hosts are making DNS requests, so it's very hard to pinpoint the actual origin of the tunnel. Sounds simple. In order to make it work, basically there is a little bit of data that needs to be sent back and forth. First of all, some flags. For instance, you need to be able to tell the server, the master of the tunnel endpoint, whether a packet is being spoofed or not, because from outside we will see all the requests coming from just one IP address, which is the IP address of the DNS server of the target network. So we need to be able to tell apart which packets are spoofed and send back our data only in packets that have not been spoofed. Otherwise, the data will be lost. So we use the flag for that. We also do that in order to create an initial handshake to make sure that the tunnel is working and to find out which encoding is supported. And we have a ticket that basically allows the server to identify which client we're talking to. So we can use the same, just one instance of the server to talk with multiple clients on the other side. So we can create actually a small botnet of a machine that we've taken over. And finally, we need two small sequence and acknowledgement number in order to be able to tell each other if any data has been lost. Keep in mind that we're talking about DNS requests, so we're talking about UDP. Delivery is not guaranteed, so we need something that allows us to actually retransmit. And pretty much this is a whole re-implementation of TCP in just 6 bytes, which has proved to be quite a challenge. So, do I have time for a quick demo of the whole thing? Okay, let's see if I can. So we have SQL Ninja here. Let me see if it actually works. Yeah. Okay. Okay, so we have this virtual machine here that's where SQL Server is running. Now, if I execute this query, who am I? It's probably hard to see it from there, but hold on a second. Basically, we're a network service, so we want obviously to try to upgrade our server to system. So what to do here? And well, I've already uploaded the exploit. I'm not going to do the whole thing. This is only the interesting bit. if it doesn't break the virtual machine. Okay. There's not much space on the screen. Oops, we're a system now. So we escalated our privileges. Now it's about time to actually run the DNS tunnel. And let me start a Wireshark first. We filter one of the hosts in order to just get the interesting traffic. Okay, I don't remember the address now on top of my head. The funny thing here is that I actually need to use 2 instances of SQL Ninja in parallel in order to make this work. But hopefully in the next version it will be a little bit more automated. It was all ready before, then I had to reboot, so it takes a little bit of time. So I'm starting here in this window, the local endpoint of DNS tunnel. So now I have my fake DNS server listening on a local port. Another window. So I tell SQL Ninja to use the interpreter extension to do a bind TCP. I'm using local host here because I have to connect to the local instance of the DNS tunnel. That's where the interpreter data will come from. And now it's starting the actual attack. It generated the exploits, converted it into a debug script, and now it's starting to upload the different lines of the script. Now it's converting the script to an executable. Checking that everything has done well and the file size is the expectant one. And I start on the other window, on the above window, I actually start the other end of the DNS tunnel. So now, as soon as the interpreter is started on the other side, I will start sending back and forth DNS requests, which we can see here. Basically here is the whole interpreter DLL now is being transferred on the server using a DNS tunnel, as we will see in a second on Wireshark. It obviously takes a while to upload the whole thing. So, I mean, the DLL, the whole interpreter package is about 700 Ks. So putting all that in DNS requests obviously requires quite a lot of traffic. But it will not take more than another minute or so. Yeah, we're almost there. Okay, we have our interpreter session, and if for instance, if I do give like ls, I can start fetching data, and if we look at the Wireshark, okay, I got the wrong, okay, I got the wrong interface. Give me a second. So we go for DNS 8. So we go again ls /. And what we have, you can see that it's all DNS requests that come from all different IPs from the network. So it's all split traffic. Oops, again. It's all split traffic in order to actually have a bidirectional channel. Can you see from back there? I can probably show you that all the IP addresses are different, and it's all DNS stuff. So a few takeaways from here. SQL injection might decline in the future, hopefully so, but we can still have quite a lot of fun with it. SQL injection is just a vector, obviously. All the techniques that we have seen are just like a bunch of techniques that can be applied to any other attack that uses any other exploitation vector. In this case, it happened to be SQL injection, but it can be anything else. Token injection, VDM abuse. If you're in charge of a network, make sure that you have a proper patching process. My advice to clients is that the patching process should have a release cycle that can be measured in days or hours, never weeks or months. So make sure that it's quick and it's reliable. Regarding protocol tunneling, that was just an example. Again, it can be done with any protocol. DNS has happened just to be one that I like to play with for a while. So if you're in charge of a network, of some firewalls, be sure that to be very paranoid when it comes to firewall policy, and make sure that your switches are configured to detect spoofing. Most switches now allow to detect this kind of attacks. Just very few administrators, in my opinion, should enable this kind of checks. Do it. As promised, there was not a single line of SQL, so a few credits, and there's time for some question, or maybe we can do it later at the bar. I ask the organizers. Okay, no questions. Was that clear? Okay, thank you.